Hello all. Today we'll be discussing about the evolution of master slave JK Flipflop. As in my last tutorial I've discussed about race around condition. That was when J input was 1 and K input was 1 when the clock was high. So what we have seen in the output was something like this. It was continuously toggling. This is the block diagram for the JK flip-flop and this is the circuit diagram. Let me revise you what we have done in that. When clock was made high, then J is 1, K is 1. As it's the NAND gate, I cannot comment on the output directly for J star and K star. So what I will do is I will assume Q of T to be 0 and Q of T bar to be 1. So if it is 0, so 0 is sorted, this Q of T is sorted over here and this Q of T bar is sorted over here. So this will be 1. So if all three are high, as clock is made high, if all the inputs are high, for NAND gate my output will be low, and if any one of the input is low my output will be high. Any one of the input is low, my output will be high. So this 1 will be followed over here and 1 output will be 0. That means Q of T now it has become 0. What if again it was 1? So 1 will be sorted over here and this 0 is sorted over here. So this will be changed into 0. If any one of the input is low, my output will be high. If all three are high, my output will be 0. Now if any one of the input is low, again my output will be high and this will be sorted over here. So 1 and 1 is 0. That means as you can see the output is changing from 0 to 1, 1 to 0, 1 to 0, 1, 0 to 1. That means it is keep toggling itself. So this kind of cases is called as racing and the entire condition is said as race around condition. In order to eliminate such kind of situation, the evolution of master slave or edge triggering came in picture. Now I'll be discussing on edge triggering. Before that, what if, so as you all know, in order to generate the output, there will be, as we have used a NAND gate, there is a propagation time required for the NAND gate in order to generate the output. So what if the propagation delay is much more? If the, say this is entire time period t and this is t by 2 and this is t by 2, what if I say you that the propagation time required by this NAND gate is greater than t by 2? If it is greater than t by 2, that means the output itself won't generate. If the output itself won't generate, or it will be holding 0 for certain time, for and as it is greater than t by 2, so the next toggle it won't be possible. That means one condition or one solution would be if your propagation time for the NAND gate is much greater than t by 2. Here as you are using the case of flip-flop, so you can say the propagation time required by the flip-flop is greater than half of the time cycle that you have provided in this clock. So this is one of the method in order to eliminate race around condition, and another one is master slave JK flip-flop. So as we have discussed over here how to overcome the race around condition, one is master slave JK flip-flop, which now will be discussing, and this is also known as edge triggering, and another one is half clock period should be less than flip-flop propagation delay. That is, just now we have discussed about that propagation flip-flop should be greater than half the time of the clock period. So let us discuss now about master slave JK flip-flop edge triggering. So what will be the scenario? As you have seen, the in the JK flip-flop, the output from here, that is the output of Q of T, was sorted as the input for this, and the output from here was sorted as the input, that we called it as feedback. Now what we can do and what modification we will do, I will be providing a clock, but here I am providing a NOT gate. That means it is defined as edge triggering. Suppose if this is high, this will be acting as low. If this is low, this will be high. And the operation of this is called as master. That means master will be giving the command, as we are providing the input first over here. So the output of this will be acting as master. The output of this will be acting as slave. So let me call it as QM, QM bar, QS and QS bar. Now what I will do is the output of QS will be acting as one of the input for this gate. Let me draw. And the output of this, that is QS bar, will be acting as one of the input or as a feedback for this NAND gate. Say this is J and this is K. Now what about this output? So this output I will be connecting as over here as the input for to drive the slave. That means the output of master flip-flop acts as the input for slave. That means this is driving the entire circuit. Now let us see what happened to our case. That was when j is 1 and k is say 1. If j is 1 and k is 1, imagine q of s to be 0 and qs bar to be 1. So as this is the input, so I'll substitute 0 over here as clock is high in this case. So I'll make clock as high and qs bar, that is 1. As you can see, 1 1 1, the output is nothing but 0, and for 1 1 0, the output will be 1. If any one of the input is 0, my output will be high. So this 1 is sorted over here, 1 and 1, the output will be low, 0 again. Now as you can see, the clock, as clock is 1 over here, the clock will be 0. So what you will do is, as the output of this is acting as the input, so this is 0, this is 0, this is 1, and the clock is 0. So if both are 0, my output is what? High. And if any one of the input is low, that is, if any one of the input is low, my output will be high. So as you can see, 1 and 0, as this was 0 earlier, so what I will do, I will sort this input 0 and 1. So 0 and 1, my output will be 1, and this 1 will be falling over here, so 1 and 1 is 0. That means what you see, if qm is 1, my qs is 0, and if qm bar is 0, my qs bar is 1. That means it is toggling the case. Now let us explain the same scenario. What if qs would be 1 and qs bar would be 0? If it is 1, as you can see, this is the input, so it will be 1, and this 0 implies the value for this will be 0. If any one of the input is 0, my output will be high, and all three are high means my output is 0. Again, if any one of the input is low for the NAND gate, my output will be high. So this 1 is sorted over here, this will be the circuit. If any one, this is 1 and it is sorted over here, so my value will be 1 over here. So 1 and 1, the output will be low, that is 0. Now qm is 0 and qm bar is 1. When qs is 1, qs bar is 0. That means this is how we have avoid the race around condition. That means if master is 0, slave will be 1. If master is 1, slave will be 0. So this is the way how we overcome race condition. So what we can say is, if clock is say high, when clock is high, imagine qm to be 0 initially. So qm will be changing as 1 0 1. This is the case when j and k are made as high, and qs will be just opposite to it. That means it will be 0 till here, and then it will keep toggling. That means it will be negative. As for qs, the clock is not of 8. That means for the negative edge it will be driving, so it will be something like this. So it will toggle in this kind of situation. So this is how we have eliminated the race around condition. Hope this tutorial is clear to you all, and this is the circuit diagram which will be used for master slave JK flip flop. Thank you.